In this video, we're going to introduce two-port network. The two-port network, as the name implies, has two ports. Ports are defined as, if you want to think about it as traditional inputs and output, but it doesn't really, V1 doesn't necessarily have to be the voltage of the input or V2 be output. It just simply says in a given circuit, we have picked 2 points A and B and 2 ports between C and D, and we will write matrices that relates voltages and currents together, and depending on what we're trying to accomplish, that matrix will change. We have typically 5 or 6 very common form of this two-port network model that we come up with. It is very heavily used. It's used to analyze various kinds of electrical devices, including filters, including transistors, and all of those devices. So a two-port network, the one requirement, the way it looks is just what we have described here, and it has a number of requirement. In order for us to be able to analyze this as a two-port network, we have to have a number of requirements put on it. So here are some examples of these requirements. First of all, the circuit inside the two-port network here, it cannot include any device that stores energy. Just to back up, it could include R, C, L, and independent supplies of any sort. Dependent supplies of any sort. But it cannot, for example, include independent sources or batteries or things like that. So it cannot have anything that stores energy, cannot have anything that independently generate energy. But it's okay to have R, L, C, and dependent sources in it. The other requirement is that the current that goes into A must be the same current that comes out of B. And if you notice, this is a passive convention. All the port parameters I1, V1, V2, I2 adhere to passive convention. Same as we said, I1 is what goes in, must come back up. I2 also must be what comes out of here. So in other words, the current coming in and going of each port balances out to 0. Okay? And the last requirement is that all connections to the external world are only through these two ports. There is not another port that is not shown here. This is an enclosed device, and then this device can only be connected to either through port 1, AB, or port 2, CD. We write these parameters that describe some relationship between I and I1, V1, I2, and V2. And probably one of the most common one that we write, is the first one on this list. Is called the impedance parameter. And what it does, I'll write the equations first. It basically says that V1 is equal to some parameter 1 times I1 plus some parameter 2 I2, and V2 is equal to Z21 I1 plus Z22 I2. As you can see, the subscript follow the row and column, because most of the time we like to write this in a matrix form, and when we write it in matrix form, we can write it as V1, V2, and this is the model. This is the impedance model and the parameters. So this would be Z12, Z21, Z22, and that is So typically when you get a device, or if you want to characterize a device, you basically need to only provide this matrix. And since it's a Z parameter, we know that it relates the current to the voltage. So V1, we understand, because we know how the multiplication of matrices go, V1 is equal to Z11 times I1 R2, which gives us the first equation, and V2 is equal to Z12 times I1 plus Z22 times I2, which gives us the second one. So this matrix is really what the model is all about. By having this matrix, we are able to completely describe our circuit without having any of the schematics or the drawing that shows how the components are connected. Now, depending on which industry you are in, you will have different ones. For example, there is one called admittance. As the name implies, it relates currents to voltage through the matrix. And then the hybrid is a combination of current voltage. Inverse hybrid is the reverse order of those things. And transmission line is specifically designed, as the name implies, for analyzing power systems, transmission lines, and things like that. In future videos, we will take each one of these models, impedance, admittance, hybrid, inverse hybrid, or transmission, and we'll explore how to use them to characterize circuits, and also how to use them to relate input one port to another port. That brings us to the end of introduction to two-port network.